Hello viewers, in today's class we are going to discuss the continuity of greatest integer function at this point x is equal to 3 by 2, right? So here we'll see whether the greatest integer function is continuous or discontinuous at the non-integral points, right? See, we know that the greatest integer function is discontinuous function at the integral points, that is 0, 1, 2, -1, -2, and so on, right? So the greatest integer function is discontinuous at the integer points, right? And here we have to discuss the continuity of this greatest integer function at the non-integral point, right? So here we have x is equal to 3 over 2, that is 1.5, right? So let us see how we can prove the continuity or the discontinuity of this greatest integer function at x is equal to 1.5. So now in order to find out the continuity or to prove the continuity of any function, we need to find out the right hand limit and the left hand limit, and both these limits should exist and finite and equal, right? And moreover, these two limits must be equal to the value of the function at the given point, right? So here if we take the point as x is equal to a, then we must have this condition for the continuity of any function. Now let us first find out the right hand limit, right? So the notation for the right hand limit is limit x tends to a, and here we have a positive sign, and here we have the function f of x, right? So here the point of consideration is 3 over 2, that is 1.5, right? So here we have 1.5 or 3 by 2. So now we can write limit x tends to 3 by 2 plus, and for f of x we can now write greatest integer of x, right? So here the positive sign shows that we are approaching towards x is equal to 3 by 2 from the right of x is equal to 3 by 2, right? So now here we'll to move further, we'll substitute x is equal to 3 by 2 plus h, right? Where h is a positive quantity, and this is a very small quantity, and it lies between 0 and 1, right? So when we take x is equal to 3 by 2 plus h, and when x tends to 3 by 2, then obviously h tends to 0, right? So now the right hand limit can be written as a limit, here x tends to 3 by 2 plus, so now here we can write h tends to 0, and for greatest integer of x, we can now write 3 by 2 plus h, right? So now let us write the value of the greatest integer of 3 by 2 plus h, right? So now we can write limit h tends to 0, and here we have 1.5 plus h. Now let us observe this quantity inside the greatest integer function symbol, right? So see, here we have 1.5 plus h, and we have already said that h is a positive quantity, but h is a very small quantity, right? So h lies between 0 and 1, it is very small, right? So 1.5 plus h is slightly greater than uh, it is greater than 1, and it is less than 2, right? So this quantity 1.5 plus h is greater than 1, but it is less than 2. It implies that 1.5 plus h lies between 1 and 2, right? So now the from the definition of greatest integer function, we can now write the value of greatest integer of 1.5 plus h is equal to 1, right? So this limit is now equal to 1. Now let us find out the left hand limit. So the notation for left hand limit is the limit x tends to a minus, and here we have f of x. So now we can write here the value of a is 3 by 2. So we have x tends to 3 by 2 minus, and here we have greatest integer of x, right? So now what we will do here, in case of right hand limit, we have substituted x is equal to 3 by 2 plus h. Now here we'll take x is equal to 3 by 2 minus h. Why? Because in this case we are approaching towards x is equal to 3 by 2 from the left of x is equal to 3 by 2, right? So we are now here in the neighborhood of x is equal to 3 by 2. So this point is actually 3 by 2 minus h, and this point is very close to x is equal to 3 by 2. And similarly, in case of right hand limit, we had this point, and this point was 3 by 2 plus h, and again this point is also very close to x is equal to 3 by 2, right? So these 2 points are in the neighborhood of x is equal to 3 by 2, right? So now we can take x is equal to 3 by 2 minus h. So when x tends to 3 by 2, h tends to 0, right? So now here we can write this limit in terms of h. So we have limit h tends to 0, and here we have greatest integer of 3 by 2 minus h, which is limit h tends to 0, and here we have 1.5 minus h. So now let us take this quantity, that is 1.5 minus h, right? Now this quantity is again greater than 1 but less than 2, because see, h is positive, right? And h lies between 0 and 1. So when we subtract h from 1.5, then this entire quantity is greater than 1 but it is less than 2, right? So 1.5 minus h lies between 1 and 2. So again, by definition of greatest integer function, the value of greatest integer of 1.5 minus h is equal to 1. So this limit is equal to 1, right? So viewers, here we have seen that the right hand limit is equal to 1 and the left hand limit is also equal to 1, right? So right hand limit is equal to left hand limit, that is equal to 1, right? Now let us find out the value of f of a, and f of a is f of 3 by 2, and here we have the value of f of 1.5, right? So f of 1.5 can be obtained by taking x is equal to 1.5 over this function. So here we have greatest integer of 1.5. So the value of greatest integer of 1.5 is equal to 1, right? So now we see that the right hand limit is equal to left hand limit is equal to f of 3 by 2, and all these three quantities are equal to 1, right? So now we see that this function, that is greatest integer of x, it satisfies this condition, that is right hand limit is equal to left hand limit. Both the limits exist and they are finite and equal to 1, right? And moreover, the right hand limit and the left hand limit both are equal to the value of the function at this point, that is 1.5, right? So now we claim that this function, that is greatest integer function, is continuous at the non-integral points, right? So here we have the point x is equal to 1.5, and this is a non-integer, right? So the greatest integer function is continuous at the non-integral points. Now here